So now metals we are using for different electrical applications, electronic and electrical applications. What made these solids more useful for electrical and electronic applications? Then how can you classify these solids with respect to these properties? What are those properties? That and all we are going to study under this concept. Are you ready? Okay, fine. Now, here, what do you mean by electricity? Flow of electron is known as what? Electricity. You know that. Current, right? Current is nothing but flow of electrons. So, until there is a flow of electron, you can't say solids are exhibiting what? Electrical property. Okay. Now, let us see whether there is a flow of electron. If it is so, when there is a flow of electron takes place. So, up to what range that electrons can flow in solids. How exactly all these things we are going to study under this concept, electrical properties of solids. So, heading I am going to take up now for today's discussion is electrical properties of solids. You know very well, solid means what? There is a close packing arrangement of what? Constituents in all the three-dimensional form. And the atoms, ions or molecules are not free to move. They are held together by what? Strong covalent force of attraction. So such type of constituents are known as, what do you call it as? Solids. So they will have definite mass, shape as well as volume. You know that one, right? Okay, fine. Now, I'm going to take this discussion now. Here, mainly based on their electrical conductivity. What do you mean by conductance? If any substance, if it allows either electrons or ions to flow through it easily, that we call it as what? Conductor. You know very well, right? So conductivity means the ease with which it allows current or electrons to flow through it. That we call it as conductivity. So if that electrical conductivity property is considered, you can classify these solids into mainly three types. Now, please don't get confused. Classification of solids based on their electrical conducting property. See now, how many types of solids are there based on their electrical conductivities? That means there are three types, you know very well. So, first one is what? Insulator. See, the first type of solid is what? Insulator. Second one is metallic conductor. Okay. Third one is semiconductors. So there are three types of solids based on their electrical conductivity. What is the first one you are seeing here? Insulator. What do you mean by insulator? Name itself is indicating that it will not conduct what? Electricity. That we call it as insulator, right? Then why? Based on what exactly you can classify this is an insulator, conductor or semiconductor. See here, in insulator here, the conductivity range is very low. In insulator, conductivity range is very low. So, here what is the conductivity range in insulator? If you take here, conductivity range between 10 power minus 20 to 10 power minus 10 ohm inverse, meter inverse. Okay, here specific conductance. In terms of specific conductance, I am expressing conductivity here. So, what is the range? In case of insulator, the conductivity is very low. How much means? 10 power minus 20 to 10 power minus 10 ohm inverse, meter inverse. Because conductance is a reciprocal of resistance. What do you mean by resistance? If there is a opposition for the flow of electrons, that we call it as resistance. Okay, because here conductance is measured between the two electrodes of 1 centimeter apart and area of cross section is 1 centimeter square. See here, conductivity means how we will measure means by using a conductivity cell. See this, how you will get this unit that I am telling here. See, for example, you have taken a solution, okay, in which when you are immersing a conductivity cell, this is a conductivity cell like that you assume. So here I will take different color to show these things for you people. See, for example, observe here. Now this is a beaker like that you assume. Now in which conductivity cell, what do you mean by conductivity cell? It is an electronic device which is used to measure the conductance, that we call it as a conductivity cell. You know very well, cell means it must have pair of what? Electrodes. So here the two electrodes we are using in conductivity cell are two platinum electrodes coated with platinum black. So these are the platinum strips that we are using as what? Electrodes. Now these two electrodes terminals are connected to a electronic device, external electric circuit. See, like this. So this is a conductivity cell. Okay. So this is a conductivity cell. Now in these two conductivity cells are immersed into a solution. Now you want to determine the conductance of this solution, like that you assume. So this we call it as a test solution. Here the distance between the two electrodes. Now how these two electrodes are placed, it means the distance between the two electrodes is 1 centimeter. Whereas area of cross section of these two this electrode is 1 centimeter square. So here cell constant, like that we will tell one parameter with respect to this conductivity cell. Cell constant, Cc means cell constant, that is equal to L by A. L means length or distance between the two electrodes. A means area of cross section. See, L is equal to 1 centimeter. Area of cross section is 1 centimeter square. So you will get what? Per centimeter. Okay, that's what unit for conductivity cell. Unit for conductivity. Conductance is a reciprocal of resistance. For resistance, ohm. Okay, now here conductivity, ohm inverse or mole, like that we can call, because it is a specific conductance per centimeter you will get. So unit for conductance is what? See here, per ohm per meter, either per ohm per centimeter or per ohm per meter. If the distance is 1 meter, then we will call per meter. If distance is per centimeter, then it will be per centimeter here. 1 centimeter means per centimeter. Okay, like this. Now insulator means, so for what I explained, why unit for conductance is per ohm per meter we are taking here. Per ohm means here, because conductance is the reciprocal of resistance, ohm inverse. Okay, and here this is a specific conductance we are taking. So unit is per ohm per meter. If the conductance of solid is between 10 power minus 20 to 10 power minus 10, then it is a very low conductance. So where you will come across this type of conductance, where the conductivity is between 10 power minus 20 to 10 power minus 10, that type of solids, we call it as what? Insulators. Now what do you mean by insulators? Insulators means the solids which exhibits very low conductivity. So what is the range of conductivity here? Between 10 power minus 10 to what? 10 power minus 20 to what? 10 power minus 10. Ohm inverse, meter inverse. So such type of solids are known as, what do you call it as? Insulators. I hope you are following. Okay. So now, what is the second type of solids that you can have based on their electrical conductivity value? See, there are some solids in which, if we observe the conductivity range between 10 power 4 to 10 power 7, okay, 10 power 4 to 10 power 7, ohm inverse, meter inverse, then such solids are known as what we call it as conductors. Now, the second type of solids are what? Conductors. Now, what do you mean by conductors? They are the solids. They will have good conductivity range only. So what is that good conductivity range? 10 power 4 to 10 power 7. Okay. So that we call it as, what do you call such solids as? Conductors. Okay. So you know very well, metals are very good conductors, right? Here, next, third one is what? Semiconductors. The third type of solids based on the electrical conductivity value is what? Semiconductors. What do you mean by semiconductors? These are the solids whose conductivity value is between what? Insulators and conductors in general, we can tell. Or else, here, when you consider values, the solids where if the conductance is between 10 power minus 6 to 10 power 4 ohm inverse, meter inverse, then such type of solids are known as semiconductors. So this value is between insulator and conductor values. So now semiconductor means they are the solids where the conductivity is intermediate range. What do you mean by that? In between of that insulator and conductor. How much means? 10 power minus 6 to 10 power 4 ohm inverse, meter inverse. So such type of solids are known as, what do you call it as? Semiconductors. I hope you are following now. So with this, what we can say, based on the conductivity values that we observe in the solids, we can classify solids into three types. Yes. So one is what? Insulator. Second one is what? Conductor. Third one is semiconductor. In detail, I am going to discuss. Is it clear? Here only based on the conductivity range value, I have classified solids like this. Okay. Please don't get confused. You have to remember all these things. What is the conductivity value range in insulator, conductor and semiconductors? Okay, fine. Now, here, how exactly you can able to classify conductors? So, what enables us to group certain solids as conductors, certain as insulator and certain substances as what? Semiconductor means here, that is explained by what? Band theory. So, one theory is there that we call it as band theory. See, here when you consider any element, electrons are grouped in a packet form. For example, 1s2, 2s2, 2p3, like that, no? So, that we call it as, what do we call it as? Atomic orbitals, right? When the atomic orbitals overlap, combine, atomic orbitals of an atom combine, what you will get? Molecular orbitals. So, these molecular orbitals, when they come very close to each other, form a band. Okay. So, that band means here, there are two types of band. One is known as valence band and another one is known as conduction band. So, in a metal, how many bands will be there? Two bands. One is known as valence band and second one is conduction band. Valence band may be partially filled or completely filled and conduction band always empty. Okay. So, here, what do you mean by this molecular orbitals? How do you get molecular orbitals? Due to the overlapping of what? Atomic orbitals. You will get what? Molecular orbitals. See here, molecular orbitals are formed by the combination of what? Atomic orbitals. Right? Now here, these atomic orbitals have almost equal energies. Okay. So, what is going to happen when all the molecular orbital energies remain very close to one another? Then we call it as what? Energy bands. Okay. So, here the energies, equal energies. So, that remain very close to one another results in the formation of what? Energy bands.